if we're launching Starship at scale, then by far the cheapest way to do AI compute will be in space. So once you have full and complete reusability, the propellant cost per flight is maybe $1 million.
Yeah, people don't realize that. People have some
to 200
ridiculous amount of expectations how much it costs.
So if you look at
it's called $1 million of transport for 10 megawatts. Like if say high altitude sun sink, it's probably more like 150 tons. But yeah, it's the right order of magnitude is at least it's in excess of 100 tons for a marginal cost per flight of around $1 million. People think like everything's just going to be covered in satellites. So I think it's not quite that. I mean, I think you have to like what mass ends up becoming satellite. Mercury probably ends up being satellites.
Yes.
Jupiter, yeah. Saturn.
It's a little gassy.
Oh yeah.
It's big.
There's got a lot of rocks orbiting.
Do you leave Mars alone? But
I think
insanity.
Absolutely audacious.
Yeah.
I say hope.
How do you feel about that? What's changed? Do you feel that way? I mean, the scope of what your ability is. How do you self-reflect on that?
Well, I've had to solve a lot of problems in a lot of different arenas, which you get this cross-fertilization of knowledge, of problem solving. And if you problem solve in a lot of different arenas, then like what is easy in one arena is trivial in is like what is trivial in one arena is a superpower in another arena. It's sort of like planet Krypton. You came from planet Krypton type of thing. So planet Krypton, you'd just be normal. But if you come to Earth, you're Superman. So if you take, say, volume manufacturing of complex objects in the automotive industry, I had to work on solving that. When translated to the space industry, it's like being Superman. Because rockets are made in very small numbers. Right. If you apply automotive manufacturing technology to satellites and rockets, it's like being Superman. Then if you take advanced material science from rockets and you apply that to the automotive industry, you get Superman again. That came from planet Krypton. Back in planet Krypton, this is normal. At this point, I guess everything ultimately converges in the singularity.
Yeah, that's what I think too.
You have lots of different parts of the puzzle that you get to play with.
I don't think it's easy. That's why, it's not like I think it's a simple thing to solve. I think it's a hard thing to solve, but it must be solved. I've come to the conclusion that
would it be solely captured by you, or would it be an asset for the U.S.?
Look, I'm just saying that we're gonna hit a chip wall. If we don't do the fab. So we have two choices: hit the chip wall, or make a fab.
But TSMC, for whatever reason, is massively worried about overbuilding, which is insane. But the whole world will be stuck with a shortage of chips forever.
So they are actually. I don't know if they're right for the right reason, but they're right.
How so?
Because it's actually like, what is the limiting factor at any given point in time? The limiting factor, if you say like by Q3 next year, like in 12 months, the limiting factor will be turning the chips on.
Power. Just power.
You need power and all of the equipment necessary, power and transformers and cooling. So it's not like you can just sort of drop off some GPUs at the power plant.
And you vertically integrated that.
You've got it
again within XAI, didn't you?
Sorry?
You vertically integrated that inside of XAI.
We designed our own transformers.
Yes, and your own cooling system.
Yes.
But they're worried that if they make more than 20 million GPUs, like they make 40 million instead of 20 million, that 20 million will not find a source of power.
Well, they won't be bought because
if there's anything missing that prevents them from being turned on, they cannot be turned on.
Yeah.
So they've got to have a power plant with enough power. So you've got to have enough gigawatts. Then you've got to convert that from probably coming out of a power plant at 100 to 300 kilovolts type of thing. you've ultimately got to convert that down to several hundred volts at the rack level.
Yeah.
So if you're missing any of the power conversion steps, you won't be able to turn them on, and then you've got to extract the heat. So it's a big shift for the data center world to move to liquid cooling, because they've used air cooling.
Yeah.
The consequences of a burst pipe are very substantial. So if you blow a pipe, a water pipe in a data center,
Yeah, no, I've seen
you
that.
just fragged $1 billion right there.
It just seems inconceivable to me that, like, if I had those chips, I would find a way to turn them on. The value of the intelligence coming out the other side so far outweighs the complexity of trying to find a way. There would be a way.
But it's just a crossing of the curves. So if chip output is growing exponentially, but power harnessed is growing in a sort of slow linear fashion, then
Which
the
is what's
exponential chip
happening
output.
right now. Right.
Exactly.
Is chip output growing exponentially? And it's
Yes.
like on very slow exponent if it's growing exponentially. It's
For high power AI chips, it's growing exponentially.
Oh.
like if we do 20 million GPUs next year, what are we talking about the following year? Like 22 million, 24? I mean, I don't see the fabs coming online, but maybe.
So we have two issues to solve.
You have to like sort of pick a point in time and say what is the limiting factor at any given point in time. So I'm not saying that power will be forever the limiting point. It's just if you say pick a date and say at this point is our chips limiting factor, our power is the limiting factor, or power conversion equipment and cooling. So it's sort of, you need transformers for transformers. This is a very hard thing. It's much harder than people realize. So for XAI is going to have the first gigawatt training cluster at Colossus 2 in Memphis. In order for us to do that, we had
Like this month, right? Next month or two?
like mid-January.
Yeah.
So mid-January will be a gigawatt at Colossus 2, not counting Colossus 1. And then 1.5 gigawatts probably in like April or April-ish.
Incredible.
So this is of coherent training.
These are the first B200s.
These are GB300s.
Okay. First ones off the line to get flipped on.
Yeah.
That's incredible. And those are like
but the
8X.
XAI team had to pull off a whole bunch of miracles in series for this to occur.
Yeah.
Like, even though there are 300 kilovolt, there are multiple high voltage power lines going right past the building, in order to connect to those, it takes a year.
Oh no!
Yeah.
You built the entire thing and you're still not connected. My God.
So we had to cobble together a gigawatt of power.
Natural gas.
Yes, with turbines. That range in size from 10 megawatts to 50 megawatts to get to a gigawatt. There's a whole bunch of them. And you've got to make them all work together, manage the power input, and then you've got to use a bunch of megapacks to, like when you do the training, the power fluctuations are gigantic.
Yeah.
So the generators, it drives generators
damn
crazy.
all collect.
Generators want to blow up basically because they can't react. If there's like 100 milliseconds, it's like a symphony.
Yeah.
And the whole symphony goes so quiet for 100 milliseconds. Generators lose their minds.
Yeah.
So
It's like Marvin the depressed robot.
Those issues.
yeah, so you've got megapacks that are sort of doing the power smoothing, but XAI had to build a gigawatt of power, and there's not a lot of like gas turbine power plants available. Like XAI bought them all.
on demand, and you can go buy your local nuclear
and
fission
there aren't
plant.
That's all training time issues, though. If by some miracle TSMC doubled its productivity and turned it all into GB300s, and you couldn't find a way to use them in a bigger training cluster, you would still have infinite demand at inference time sprinkled all over the world, and you could park them there for 6 months and then bring them back to training. There's no way those things will not get turned on somewhere somehow.
It's not that they won't ever be turned on, but I'm just saying that the rate of
Rate limiting steps.
this is my prediction. I could be wrong, but my prediction is that that TSMC's concern is valid. I don't know if it's valid in my opinion for the reason that it is possible for chip production to exceed the rate at which the AI chips can be turned on. Because you don't just have the GV300s. You got the Amazon's got the Trainiums, Google's got the
Yeah, it's all go into TSMC though. Almost Samsung a little
the vast
bit.
majority,
but,
yeah.
It's like a
so-
bottleneck on all of humanity.
My other son,
so-
Jet, who's 14, wanted to know about your AI gaming studio and the impact of AI in the gaming world. What are your thoughts? What are you building out? I mean, you've been a gamer for some time.
Yeah, that's why I got to start programming computers. I think I got there was like a video game set pre-Atari that had like 4 preset games. And it was basically just blocks, of one key Pong and there was like a race car game. But like it was just blocks basically, blocks on a TV.
You ever play Civ?
Yeah. So Civ is actually that's a real, in terms of games that like educate you while you have fun.
Yeah.
Civ is epic at that. It's
It is epic.
It teaches you so much about civilization, and you're having a good time.
And the only way I ever win is getting off the planet. I don't
Like tech victory to Alpha Centauri.
Tech victory. I never even start going down the culture or religious path. I just get off the planet as fast as I can.
I guess I guess I am sort of aiming for the Alpha Centauri tech victory, essentially.
It just seems like the right way to win. Yeah.